Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 15, Atoms, Molecules, and Ions, Part 2. Here are our objectives for today's video. Pause here. So we talked a little bit about ions in our last chapter. They are formed by atoms gaining or losing electrons, so oxidation or reduction, or rather other way around, to form charged particles. Cations, so they are formed from the loss of electrons to form something positively charged, for example, Ca2+. And then anions are formed from the gain of electrons to form negatively charged particles, for example, Cl-. Little quick way to help you remember, the T in cation kind of looks like a plus sign, so we're forming something positively charged. Maybe that's useful to you, maybe it's not. Pause here. So when we refer to isotopes, and we typically are referring to them in the plural sense of the word, you can have two atoms of the same element that they'll have to have the same atomic number, otherwise they wouldn't be the same element, but you can have different numbers of neutrons. And that is why when you look at the periodic table, I actually have one on my second screen, and almost all of these elements have decimal places for their average mass. So that's a number all the way on the bottom. Aside from those weird ones on the bottom where they have them in parentheses, and that's because most of those are man-made and there's only one isotope of them, but all, pretty much to the best of my knowledge, all of the naturally occurring ones have more than one isotope. I could be wrong about that. I'll have to look that one up later. Pause here. Right, so let's work through this. So both of these are magnesium. So because it's magnesium, its atomic number is 12. This one gave us the mass number 24. And then because it has a 2+ charge, I just have to label it. Again, since it's magnesium, its atomic number is 12. It says now this time 13 neutrons, so I have to do 12 plus 13. So 25 is the mass number. It's magnesium. And then it says it has 12 electrons, so there's no charge, so I don't need to label any sort of charge. It's not, I guess it wouldn't necessarily be wrong to put a 0 there, but it's not something you'll ever see done, so I wouldn't do it. Pause here. Okay, so now we're going to need to be able to know, just by looking at the periodic table, what the type of elements are. So there are 3 types. There's metals, nonmetals, and metalloids. So metals, so you've seen these before. These are shiny. That's because we've got these freely moving electrons between the S and the D subshells, and also the S and the D electrons tend to be pretty loosely held, so they're able to reflect light. They conduct heat and electricity. Again, for those same reasons, we've got these freely moving electrons. That's what you need to conduct electricity, is freely moving charged particles. It doesn't necessarily have to be electrons. Malleable, which means it can be hammered into thin sheets, and ductile, meaning it can be pulled into wires. Then we have our nonmetals. You have a little bit more variety. When I say that, it's like some of them are gases, some of them are solids, some of them are liquids. You don't tend to see these sort of cohesive properties like we do with metals, but they typically don't look like metals. But you have, aside from not looking like metals, there don't tend to be that many cohesive properties. And then we have our metalloids, which have some properties of metals, meaning a lot of them are what's called a semiconductor. So they will conduct electricity, but they have to be warm enough to do so. All of the metals, by and large, are going to be solids. You're not going to see like a gaseous metalloid, but they don't have all of the properties of metalloids. They're typically not going to be super malleable or ductile, but they might conduct electricity, and they may conduct heat. Now let's figure out how we know by the periodic table what something is. Right, so I've got my periodic table of elements right here. And so what I do is I'm going to draw what I like to call the staircase on it. Okay. And then before I go ahead and label everything else, I'm just going to mark my exceptions. So hydrogen is an exception. It's a nonmetal. And aluminum is an exception. It is a metal. But then the elements that are on the staircase, and I'm not going to expect for you to know the other elements, these are all metalloids. When I say on the staircase, I mean it has a full face, not a corner. So all of these are metalloids. So purple is equal to metalloid. Sorry, I know I'm doing this with my fingers, so it looks kind of weird. All right, now I'm going to label my metals. I'll do those in red. So that's everything to the left of the staircase. And then when these are eventually discovered, actually, I think they have been since then, they will also be metals. And then all the ones down here are also metals. And then everything to the right of that, so I'll represent that in yellow, are our nonmetals. So there's a whole lot more metals than there are nonmetals. So I know I labeled this in green for nonmetal, but the exceptions I expect for you to know is that hydrogen is a nonmetal and aluminum is a metal. But otherwise, you can follow these sort of rules that I've outlined here, and you will always be able to figure out what type that element is. All right, that's all for tonight. Thank you so much for watching, and have a great night.